Okay, in this session, we are going to look into decoder. Decoder is an example of logic, a combination logic circuit. So decoder is opposite of encoder. Now decoder is a circuit where it has multiple input and multiple output. So it will convert the coded input to coded output, where input and output will be of different type. So this is the general structure of decoder, where you have n input and output will be 2 raised to power n. Now in case of encoder, so if you recall what we have studied in encoder, so in case of encoder, you have input 2 raised to power n and output n. So which means encoder and decoder are opposite in terms of input and output. Now, in the last sentence, it says the encoded information is presented as n input, which will produce 2 raised to power n possible output. Now, we will look into one type of decoder, that is 2 to 4 line decoder, where you have 2 input and 4 output. When we say 2 to 4 decoder, the value of n is 2. So output will be 2 raised to power n. Here we have n equal to 2, therefore your output will be 4. And 3 to 8 decoder will be homework for you. Now in this circuit diagram, that is logic diagram, so this is the 2 to 4 line decoder, which is constructed using n gate, and you have a truth table out here. Now I will explain the truth table. You have input A and B. So this E is an enable, and output Y0, Y1, Y2, and Y3. Now this E is enable. So this is an important terminal in the decoder where it will enable your device. Now when you give E equal to 0, that device will be disabled. When you give E equal to 1, then your device will enable. Now with the help of E, your device will start working. And you have input A and B. Now if you look at the truth table, when you give E equal to 0, that means input A and B will be don't care. So here it represents by letter X, which means whether you give input 1, 0 for both A and B, since E is equal to 0, so that is the device is at the state of disabled, so therefore your device will not work. So therefore it is don't care stage. So therefore your output at that stage will be all 0. Y0, Y1, Y2, and Y3 will be 0. Now I'm going to explain this truth table in detail, and we will analyze how we construct this logic diagram of 2 to 4 line decoder. Now you know, for the 2 input A and B, so you know how to give the bit 0, 1, 0, 1. So this should be 1. So I have made mistake. Please correct this one, or I will correct just now. So this one is 1, and you have 0, 0, 1, 1. So this will be 1. Okay, now, so when you give 0, 0, your output display will be at Y0, at this one. So I will tell you the reason why you have output only at Y0, not at Y1, Y2, and Y3. So this one, Y0, Y1, Y2, Y3, you know that decoder output is 2 raised to power n. 2 raised to power n. What is n out here? 2 raised to power n. It is 0. So therefore, output will be displayed at 0. Now similarly, when you give input A equal to 0 and B equal to 1, that means what is n out here? 1. So therefore, 2 raised to power n, out here n is 1. So therefore, output will be displayed at this one, Y1. Now similarly, when you give input a equal to 1 and b equal to 0, so output will be displayed at y equal to 2, that is 2 raised to power n. Out here n is 2. When you give input a and b, that is 3. So 2 raised to power n, out here 2 raised to power n, what is n? N is 3. So output will be displayed at 3. Now, if you do the truth table, if you do the Boolean expression for this one using K-map, so you will get for y equal to y3, you will get AB. So AB, which means AND gate. And similarly for y2, you will have A B bar, which is AND gate, but B bar, A B bar. Similarly for this y1, you will have A bar B, and similarly for y0 you will have A bar B bar. Now if you look at y0, let's focus at y0. We say the Boolean expression will be A bar B bar. Now if you focus out here, your input A and B is connected through inverter. So therefore, in order to have output at y0, your input A and B is connected through inverter to the y0. Only you will have output at y0. So therefore, the Boolean expression for y0 will be A bar B bar. So if you have any doubt, you can drop me the message in the messenger group, or you can write email personally. Now, as I said, this one will be homework for you. Draw the circuit diagram of 3 to 8 decoder and explain the circuit diagram. First, you have to draw the truth table. So you know how to draw the truth table. For this one, you will have 3 input A, B, C, and you will have enable, and you have 8 output. Depending on the input, you have an output display, as I explained in the previous type of decoder, that is 2 to 4 decoder. So now for each output, you will have the Boolean expression. With the help of Boolean expression, you can draw the logic diagram for 3 to 8 decoder using AND gate. So I'm going to correct this one, and you should submit next week. Now we will look into the 7-segment display. So there is a decoder which is called BCD to 7-segment display decoder. So this is the device where it will convert the BCD input to binary number. For example, the most digital equipment has some means for displaying the information from that which can be understood by the user. So the user will understand the decimal number than the binary number. So therefore, with the help of BCD to 7-segment display, so your binary number can be converted to decimal number. So one of the simplest and most popular method for displaying numerical digit use the 7-segment conversion to form digital character from 0 to 9, and sometimes the hex character from A to F. Now in this diagram, so this is the BCD to 7-segment display decoder, where you have input, which is BCD, that is binary number, and you have output out here, where you will have the decimal number. With the help of this display, you will have number from 0 to 9, sometimes even the hexa character A to F. So this is the main device where it convert your binary to decimal number. So this one device is known as BCD to 7-segment decoder. Now let's look at how it convert from binary to decimal. Now, if you look at this truth table and this display, this is the display at the output, and this one is the truth table. With the help of truth table, I'm going to explain how 7-segment display decoder is converting the decimal number to binary number to decimal number. Now in the input side, you have a 4-bit ABCD. Now in order to display 0, so digit 0 which is equivalent to 000. Now in order to display 0, which LED should be glow at this output? Every LED will glow except G. So this will be turn off, rest will be glow. So which means it will be display 0. Now if you look at 9, so binary number 9 will equal to is 1001. So which means this one 1001 is 9. Now in order to display 9, so if you look at this display, so in order to display 9, so if you draw the 9, so only E should not glow, rest it should glow all. So therefore in the truth table it is shown that E is 0, rest 1. So therefore you can display 9. So this is the K-map simplification that is done for the output. And this is the logic diagram for BCD to 7-segment display decoder. So what is more important out here is to understand the 7-segment BCD to 7-segment display decoder, how the conversion is taking place. Now this is the type of IC for BCD to 7-segment display. So we have a different version of IC like 7446A, 747A, LS. So these are the type of IC that we have for BCD to 7-segment display. Now in the 7-segment display we have two types. First one is common anode and common cathode. So we are categorizing 7-segment display into two types, common anode and common cathode. So this is based on how the connection. So if you connect your anode positive terminal of LED to the power supply, so that is called common anode, I think. Now here, common anode. If you connect your positive terminal of LED to the power supply, then that is known as common anode. And if you connect negative terminal of the your LED, it is known as common cathode. So this is all about this lesson, and this comes to the end for unit 2, and in the next class we are going to start with unit 3. So please be ready with next lesson, and I have given you one homework, that is to draw the truth table of 3 to 8 decoder and also draw the logic diagram and explain that 3 to 8 decoder. You need to submit to me either by email or you can send to me which is comfortable for you. Thank you for listening.